In the stillness of interstellar space, where starlight fades into nothing and time itself feels like a long-held breath, something begins to move. It drifts silently across the darkness, not a comet born of our sun, not an asteroid pulled from the familiar debris of planetary birth. It comes from elsewhere, from the deep ocean between the stars. Astronomers call it 3-eye Atlas, but behind the sterile designation lies something stranger, something that should not exist at all. The cosmos is vast, but rarely does it send us visitors. For billions of years, our solar system has orbited quietly, a self-contained island surrounded by infinite distance. Yet, in the span of a single human lifetime, 3 interstellar wanderers have crossed our path. The first, Oumuamua, slipped by in 2017, a shard of something ancient and alien, accelerating mysteriously as it fled back into the void. The second, 2-eye Borisov, followed a true comet, carrying frozen gases from another star. But the third, 3-eye Atlas, is different. It does not simply ignore the rules of celestial mechanics. It appears to rewrite them. When it was first seen, astronomers expected predictability, a curve through space shaped by the pull of gravity, a path that could be calculated, understood, contained. But 3-eye Atlas moved as though gravity were only a suggestion. Its brightness fluctuated without pattern, as if reflecting sunlight from shifting, unknowable surfaces. Its spin defied logic, a slow tumble, then a sudden stillness. Even its speed betrayed expectation, faster than any object ejected by natural means should travel. To the instruments that watched it, it behaved not as a passive stone, but as something aware of its own journey, and in its presence, the laws of physics began to feel temporary. The space between the stars was once thought eternal, a place of quiet, reliable forces. But each visitor that crosses it seems to peel away a layer of certainty. With Oumuamua, we saw motion without propulsion. With Borisov, a comet that should have evaporated long before reaching us. And now, with Atlas, we see the possibility that the universe itself is capable of acts of deliberate unpredictability that nature may be stranger than even mathematics can confess. Telescopes across the world turned. Follow it, the icy peaks of Mauna Loa, the deserts of Chile, the islands of the Atlantic, all tracing the path of an interstellar ghost. It shimmered briefly against the blackness, leaving no trail, no message, no signature of origin. Only questions. Astronomers stared into their data, and for the first time in decades, found themselves uncertain whether they were looking at a natural object, or a new kind of phenomenon entirely. Something unseen, unmeasured, perhaps even undetectable by the tools we've built to understand the cosmos. As 3-eye Atlas slipped farther from the sun's light, the silence it left behind felt heavy, not the silence of absence, but of revelation, the kind that forces humanity to look again at its oldest assumption, that the universe plays by rules. But tonight, as this visitor fades into the deep, cold dark, the illusion of cosmic order fades with it, and somewhere in the quiet hum of observatories across Earth, a realization dawns that the cosmos is not bound by the laws we write, but alive in the ways we cannot yet imagine. Astronomers look again and realize this object isn't behaving like anything they've ever tracked. If the mysteries of the cosmos move you, if you believe that every unanswered question brings us closer to truth, then join us. Subscribe and continue this journey beyond the edge of what we know it began. As such discoveries often do, not with a shout, but with a flicker of light buried in data, a small, unassuming trace on a screen that shouldn't have been there. On a quiet night in early spring, The Asteroid Terrestrial Impact Last Alert System, ATLA, has recorded something that defied familiarity. Among the thousands of routine sky scans meant to safeguard Earth from near-Earth asteroids, one data line refused to behave. It moved too fast, too steady, and from an angle that made no celestial sense. What appeared at first as a digital artifact soon revealed itself as a traveler from the deep beyond, 3I Atlas, the third confirmed interstellar object ever detected. At first, astronomers assumed a predictable story, another cosmic fragment wandering through our neighborhood, bound by gravity's immutable call. But when its orbit was calculated, a subtle unease began to form. 3I Atlas was entering the solar system on a hyperbolic trajectory, unmistakably from outside the sun's influence. Yet, as the data accumulated, the numbers betrayed something stranger still. Its path did not align with gravity's perfection. It bent where it shouldn't bend. Its velocity wavered, ever so slightly, as if responding to forces unseen. When astronomers mapped its brightness, the unease deepened. The object pulsed irregularly, shimmering brighter and dimmer without pattern, like a heartbeat of reflected light. Unlike typical comets, there was no clear outgassing, no trail of evaporating ice, no cloud of dust. Its surface seemed active, but without reason. In physics, every action has a cause, but for 3I Atlas, there was only effect. Across observatories from Mauna Loa to Paranel, from La Palma to Mauna Kea, telescopes synchronized in a rare planetary chorus. Teams cross-referenced optical and infrared data, tracking its flight across the ecliptic. Yet each night brought new anomalies. Its spin refused to stabilize, a chaotic, non-principal axis rotation, tumbling as though something within it was unbalanced or alive. Light curves revealed glints too sharp to be random, reflections off surfaces perhaps metallic, perhaps something more complex in comparison. Oumuamua, the first interstellar visitor, had already rewritten textbooks by accelerating without visible propulsion. But where Oumuamua was enigmatic, 3I Atlas was disobedient. It ignored gravitational predictions with a precision that felt deliberate. Each new observation widened the rift between expectation and reality. If radiation pressure from the sun caused its motion, the required reflectivity would exceed anything found in nature. If sublimation was responsible, then the missing vapor cloud was an impossible omission. Within weeks, what began as a mere curiosity had transformed into the most perplexing interstellar event since the dawn of modern astronomy. Reports poured into the Minor Planet Center, and astrophysicists debated quietly in private channels. Some proposed exotic outgassing from hypervolatile ices unknown on Earth. Others suggested thin-layered structures, perhaps hollow, perhaps engineered, that could interact with sunlight in unfamiliar ways. And then came the strangest observation of all, its spin rate. Instead of slowing with distance from the sun as expected, remained constant for decades. Astronomy has trusted in the cold precision of celestial mechanics, the belief that every orbit, every motion, every shimmer can be explained through gravity and light. Yet, as 3I Atlas continued its unpredictable drift, that faith began to fracture. The equations still worked, but the universe no longer seemed to obey them. Behind every telescope's lens, a quiet tension settled in. Astronomers are not prone to wonder lightly. Their world is built upon skepticism, upon data and discipline. But as 3I Atlas slipped further into the night, a word once thought archaic began to circulate again. Impossible. It was not shouted, nor printed, nor announced in any official report. It was whispered in the low hum of control rooms, in emails sent past midnight, in the silence between frames of raw data. Because for the first time in decades, the universe had done something that could not yet be understood. And the more they watched, the clearer it became. This object was not just passing through our solar system, it was passing through our understanding of physics itself. As the days turned to weeks, its faint reflection began to fade, but the mystery it left behind grew brighter than ever. 3I Atlas, the visitor that shouldn't exist, had done what few discoveries ever do. It reminded humanity that even after centuries of observation, the sky above still holds the power to make us doubt what we know. The data kept arriving in waves, thousands of measurements from telescopes spread across continents, each one deepening the enigma. At first, astronomers hoped that a clearer pattern would emerge, that noise would yield to reason. But as precision improved, the mystery sharpened. Every refinement of its trajectory, every recalibration of its luminosity curve, only confirmed that 3I Atlas was not obeying the physics that guide every other natural object in the solar system. Its velocity showed a faint but persistent acceleration, measurable, undeniable, yet impossible to assign to any known force. Teams from NASA's Jet Propulsion Laboratory and the European Southern Observatory began comparing notes, testing models of radiation pressure, outgassing jets, and gravitational perturbations. Each hypothesis collapsed under scrutiny. Even under extreme assumptions, surfaces polished like mirrors, materials lighter than aerogel, the calculations fell short. Something was pushing 3I Atlas, something neither mechanical nor gravitational. Some speculated it might be rotating in sync with internal heat variations, causing subtle shifts in momentum. Others imagined a thin, flexible geometry reacting to sunlight the way a sail responds to the wind. When the object passed perihelion, its closest approach to the sun, the anomaly reached its peak. Instead of the expected brightening and predictable curve away from solar influence, it dimmed abruptly, almost vanishing from optical sight. Then, days later, it brightened again, as if responding to some unseen alignment. The timing defied coincidence. Telescopes, equipped with spectrometers, captured faint traces of materials, hints of metals mixed with exotic ices, suggesting an origin far beyond our galactic neighborhood. In its spectral fingerprint lay elements unseen in any known comet, magnesium silicates and reflective compounds more commonly associated with exoplanetary crusts than drifting dust. Astronomers began to wonder if they were not observing an object at all, but a phenomenon, a structure formed under conditions that had never occurred within the Milky Way's familiar nursery of stars. Some dared to propose that 3I Atlas might not be a remnant of planetary formation, but a relic of destruction, the shattered debris of a world lost to its own dying sun, hurled into eternal exile by gravitational chaos. If so, it had traveled for millions, perhaps billions of years, only to arrive here, in our moment of observation, crossing paths with a species just intelligent enough to be confused by it. Amid the growing uncertainty, radio telescopes joined the effort, not to listen for transmissions, that was too speculative for official proposals, but to measure radio reflectivity, to map the way its surface interacted with electromagnetic waves. The readings came back weak but inconsistent, fluctuating in ways that implied complex geometry rather than random debris. The possibility that it was tumbling asymmetrically, presenting varying profiles to incoming light, became plausible, and yet, that very motion was what kept its trajectory unpredictable. For every answer that crept closer to new mysteries appeared. If its composition was alien, why did it reflect sunlight so efficiently? If its shape caused acceleration, Why did the pattern of motion shift without apparent trigger? The data contained harmony and dissonance in equal measure, a physical melody that refused to resolve. Scientists began to recognize a deeper truth, that perhaps 3I Atlas was not breaking the laws of physics, but exposing the limits of our interpretation of them. Gravity, radiation, and thermodynamics are constants only within the bounds of the environments that birthed them. Beyond those boundaries, beyond the familiar rhythm of our star, even these laws might bend into unfamiliar forms. And so, in a quiet reversal, the observers themselves became the observed, their instruments not dissecting the universe, but revealing the fragility of their own comprehension. For generations, astronomy has been an act of certainty, a precise language for describing the infinite. Yet here was an intruder, silent and indifferent, teaching the most humbling lesson of all, that certainty is temporary, and understanding is always borrowed. As 3I Atlas slipped farther into the dark, astronomers faced an uneasy realization. This was not a visitor in the usual sense, not merely an object crossing space, but a messenger from a region where our science has no vocabulary, a place where matter behaves like thought, and energy flows with intention we cannot measure. And somewhere, within that cold and unreachable void, lies the origin of its journey, a mystery as vast as the interstellar night itself. Far from the warmth of the sun, a cold traveler drifts in silence. 3I Atlas, the third interstellar object ever detected within our solar system, and by far the strangest. Its arrival was first celebrated as another cosmic visitor, a frozen witness from a distant star, a remnant of creation lost between the gulfs of time and gravity. But the closer scientists looked, the less it resembled anything they had seen before. Every telescope trained upon it seemed to peel back one layer of certainty, only to find another question waiting beneath. Its path should have been predictable, a smooth arc dictated by Newton's immutable equations, refined by centuries of observation. Yet it began to wander, not wildly, but in delicate, almost deliberate adjustments, subtle deviations from the trajectory that computers had so confidently drawn. To most, these shifts were barely perceptible. To those watching closely, they were revolutionary. The acceleration was too erratic for radiation pressure alone, too consistent to be chance. Even when all the mathematical dust settled, a remainder of impossibility refused to cancel out. Something, somehow, was moving 3I Atlas. Something invisible, precise, and inexplicable. Its surface betrayed another enigma. Under polarized light, it gleamed like metal, but without the heat signature that metal should produce in sunlight. The reflected brightness was sharp, mirror-like, but thermally cold, as though its surface rejected warmth itself. Astronomers measured its albedo, expecting a dusty veil or a frozen crust, and found instead a value that belonged to engineered alloys, not cosmic debris. A natural comet could not reflect so perfectly and remain so cool. A natural asteroid could not alter its spin and glide with such finesse. The light curve, when plotted over time, displayed a symmetry so balanced it seemed intentional, a rhythm in its rotation, a harmonic repetition too exact for chaos. Theories began to bloom across research papers and press releases alike. Some called it coincidence. Others, recalling the controversy of 2017, whispered the name Avi Loeb, the Harvard astrophysicist who once suggested that Oumuamua might have been a fragment of alien technology, a solar sail catching the faint breath of starlight. For many, that idea had been too bold, too uncomfortably close to fiction. Yet now, 3I Atlas was performing the same dance, only more convincingly, more eerily synchronized with observation itself. When spectropolarimetric data arrived from Chile's Cerro Paranol Observatory, it revealed faint polarization in the reflected light, a fingerprint of thin-layered structure, as if its surface were composed of fine membranes or panels, each scattering light at deliberate angles. This was not proof of artifice, but it was not easily dismissed as chance. The numbers, stubbornly consistent, implied geometry. Within days, the fascination leapt from academic circles to the public sphere. Astronomy forums overflowed with speculation, every comment thread a tapestry of wonder and argument. Is this natural? Became the most searched question in science communities across the internet. For some, the allure was existential, the dream that perhaps, at last, something beyond us had left a trace. For others, the thought was unbearable, that our understanding of the cosmos might not be as complete as we believed. NASA convened emergency coordination meetings, looping in the European Space Agency and private observatories with advanced adaptive optics systems. The race was on to capture higher resolution imagery before the object slipped away into the black, before its strange behavior became a mere footnote in cosmic history. Yet every time a new attempt was made, clouds, solar glare, or technical failure intervened. As if the object itself resisted clarity, each update from the tracking network carried a quiet undertone of unease. It was not just that 3I Atlas behaved differently. It behaved as though aware of being watched. Each burst of observation seemed followed by a subtle shift in its motion, like a reflex, a response. No one could quantify it, but many felt it, an uncanny synchronicity between the gaze of our instruments and the silent drift of this visitor from nowhere. The mystery of 3I Atlas had begun as a question of science, of motion, composition, and light. But now it was something deeper, almost philosophical. The cosmos, once thought indifferent, now seemed to glance back. And in that silent exchange between an observing species and an unexplainable wanderer, a quiet thought began to take hold. Perhaps the universe was not merely filled with phenomena to be studied, but with presences waiting to be understood. As more data streamed in from telescopes around the globe, the portrait of 3I Atlas only grew stranger. Its light, once steady and pale, began to pulse in faint intervals, a slow, measured rhythm that defied both instrumental error and natural explanation. The pattern wasn't random. It carried a consistency that hinted at structure, like the flicker of a signal embedded in chaos. Astronomers at the European Southern Observatory recalibrated their sensors, certain it was a glitch of calibration or atmosphere, but the same pattern reappeared. Identical timing, identical strength, across 3 continents, separated by oceans and hemispheres. It was as if the object itself were whispering something through the spectrum of reflected light. Its composition, too, resisted categorization. Infrared analysis revealed a spectrum that contained no clear peaks for water ice, carbon, or silicate minerals, the standard fingerprints of comets and asteroids. Instead, it displayed a smooth, metallic reflectance curve, interrupted only by narrow bands of absorption that didn't match any known natural compound. When cross-checked against the planetary materials database, the closest match wasn't geological at all, but manufactured similar to ultra-thin titanium films used in spacecraft thermal shielding. Yet, 3I Atlas showed no signs of construction, no seams, no fragments, no debris trail. If it was artificial, it was whole, impossibly intact after an interstellar voyage, lasting millions of years. The conversation among scientists began to fracture. Some clung to the comfort of physics, that a natural explanation must exist, hidden in equations not yet written. Others entertained the possibility that it represented a new class of object entirely, a phenomenon born not of chance, but of purpose. Papers emerged proposing self-regulating cometary shells, magnetic propulsion through charged dust, or unknown photonic interactions with interstellar hydrogen. Yet, beneath the academic rigor lay an undercurrent of awe and perhaps fear. For the first time, the frontier of discovery didn't feel like expansion. It felt like exposure. Night after night, the data flowed, and with it came a haunting realization. 3i Atlas was slowing down, not dramatically, but subtly, as though something within it adjusted its speed. The deceleration did not align with gravitational drag or solar wind pressure. It was selective, occurring during observation windows, then vanishing when telescopes fell idle. Statistically, it could be coincidence. But to the eyes watching through screens and mirrors, the pattern seemed too deliberate to ignore. In the dim light of observatories across the world, scientists stared at the graphs glowing on their monitors, faint lines tracing the rhythm of a cosmic enigma. It moved not as a rock, nor as ice, nor as a simple relic of formation, but as something that responded to its environment. Each small deviation carried the weight of intent. Each moment of silence between observations felt like the pause before a question. In the grand theater of the cosmos, humanity had always been the audience, gazing upward at indifferent stars. But as 3i Atlas drifted through the dark, defying prediction and expectation alike, that ancient balance began to tremble. What if this was not merely a visitor, but a message, not written in language, but in the quiet defiance of the known? The object would soon leave the reach of our telescopes, slipping back into the interstellar night. Yet its shadow would remain, not upon the sky, but upon certainty itself. For 3i Atlas had done something no discovery had managed in a generation. It made humanity question the boundaries between the natural and the designed, between the observer and the observed. And in that thin, trembling space of doubt, the universe seemed to breathe again, alive, aware, and infinitely stranger than we had ever dared to believe for most of human history. The night sky was a map of permanence, stars fixed in their constellations, planets drifting in predictable rhythms, comets returning as if bound by memory. Yet beneath that stillness, something unthinkable had always been crossing, unseen fragments from other suns, slipping through the solar system like ghosts through an unlit room. Humanity's instruments were simply too blind to notice. Only in the last few decades did the eyes of Earth finally open wide enough to glimpse them. The story of 3i Atlas began not with a single telescope, but with the patient evolution of our cosmic awareness. From the early days of hand-drawn charts to the digital constellations of modern sky surveys, the human gaze transformed into a network of artificial sentinels, machines that never blink. Instruments like Pan-STARRS in Hawaii, the Atlas survey that now bears the visitor's name, and the soon-to-be fully operational Vera C. Rubin Observatory in Chile formed a living web across the heavens. Each night, they capture the entire sky in images layered with billions of points of light, fixed, flickering, and fleeting. Within that sea of data, a handful of moving dots tell stories that began in other star systems. But to detect them requires more than glass and mirrors. It demands intelligence. As the flood of data outgrew human patience, astronomers turned to machine learning algorithms, trained to notice the nearly imperceptible shifts that reveal a visitor from beyond. Artificial intelligence now combs through petabytes of images, learning the subtle fingerprint of motion that the human eye would miss. It is through this quiet collaboration between silicon and curiosity that 3i Atlas was first found, not by a single astronomer staring into the dark, but by a symphony of observation, code, and cosmic chance. The path to such precision was written in the history of failure. When the first interstellar object, Oumuamua, appeared in 2017, it was already too late for close study. It arrived unannounced, flashed briefly through the solar system, and vanished back into interstellar night. By the time telescopes aligned to focus on it, the opportunity had passed, and with it the chance to know what it truly was. Then came to eye Borisov, discovered by an amateur astronomer in Crimea. This time, the world was ready. Its tail, a classic cometary plume, gave scientists a glimpse into the chemistry of another star's planetary cradle. And yet, even that encounter raised more questions than it answered. To visitors, two anomalies, two promises that the universe was far more open than once believed. So, when Atlas detected a faint, fast-moving point in December 2023, it was not greeted with surprise, but with reverence. Humanity had waited for this. The object was small, dim, and impossibly fast, moving on a hyperbolic path that could only mean one thing: it did not belong to our sun. Observatories across Earth mobilized like a single organism reacting to stimulus. For weeks, telescopes in Hawaii, the Canary Islands, Chile, and Arizona followed the object's flight, refining its orbit and brightness with every passing night. Even then, time was the enemy. Interstellar objects move like whispers, their approach sudden, their departure irreversible. Once they leave, they do not return. Behind the numbers and light curves, there was a deeper story, one of perspective. For centuries, humanity imagined space as a stage upon which our solar system played out its solitary drama. But each new interstellar visitor chipped away at that illusion. The cosmos, it seemed, was not a void but a living ocean, where currents of rock, ice, and perhaps even intention drifted endlessly between stars. These objects were not mere wanderers. They were messengers, carrying the chemistry, gravity, and memory of other suns. As the lineage of detection improved, so did our ability to interpret what these travelers meant. Scientists began to theorize that interstellar objects might be far more common than we'd once thought. Perhaps millions passing silently through the outer reaches of the solar system at any given time. Most would remain unseen, dark and small against the cosmic backdrop. But every so often, one would stray too close, illuminated by the light of our star, betraying its presence for a fleeting moment. The search became not just a scientific pursuit, but a philosophical one. To detect a visitor from beyond was to hold a fragment of another solar system in the human imagination. It was to realize that the void between stars was not emptiness, but a bridge. And in the detection of 3I Atlas, humanity crossed that bridge again, further than before, deeper into the unknown, guided not by certainty, but by the faint echo of motion in the dark. And yet, even as telescopes aligned and algorithms refined their gaze, there lingered a sense of unease. For this object, unlike any before it, did not behave as expected. Its motion betrayed precision, its brightness shifted without reason, and its trajectory, though mathematically hyperbolic, carried the quiet suggestion of design. The very tools built to understand it now strained under the weight of its defiance. In that defiance lay a question as vast as the interstellar sea itself. What if these objects were not simply random messengers of distant creation, but something else? What if the cosmos had always been speaking, and only now, with eyes finally open wide enough, humanity had begun to hear? That question would haunt every observation to come. For in the data of 3I Atlas, the universe was not merely revealing another object. It was hinting at a flaw in its own rules. an imperfection in the script of reality. And from that imperfection, a new mystery was about to emerge, one that would test not only the limits of science, but the boundaries of what it means to understand. As days passed, and 3I Atlas drifted further inward, the instruments designed to chase comets found themselves straining against the edges of precision. The world's greatest observatories, once content to measure the predictable ballet of asteroids, now faced something that moved like improvisation. Its track through the heavens was mathematically sound, yet emotionally dissonant. Each update to its orbit seemed to rewrite the one before, like a melody that refused to resolve. At the Verisi Rubin Observatory, still in its testing phase in the Chilean Andes, prototype systems processed the new data through layers of machine learning filters. Each pixel, each frame, each shifting speck of light was compared to decades of stored images. The AI flagged 3I Atlas repeatedly, not for its brightness, but for its inconsistency. It appeared where nothing should have appeared, and at times dimmed entirely while still moving through measurable space. To the human eye, this could have been noise. To the algorithm, it was deliberate variance, a kind of mathematical heartbeat pulsing through the vacuum. The more researchers tried to clarify the image, the more the mystery thickened. The European Space Agency's Gaia mission provided supplementary data, refining its distance and speed to impossible accuracy. Yet something was off. The object's motion deviated by fractions of a percent, small enough to dismiss, yet persistent enough to defy chance. Such minor anomalies, if repeated, were the birthmarks of discovery. Einstein's theory of general relativity had once been proven through deviations smaller than these. Could this, too, be a clue that the universe was hinting at another hidden layer of physics? Veteran astronomers began to feel a familiar tension, the kind that comes before revelation. When Oumuamua was first studied, its acceleration without visible jets had ignited a decade of debate. Now, history seemed to echo itself, but louder, as if the cosmos were replaying the same theme with different notes. The technology to observe had evolved, yet the strangeness had grown alongside it. Some researchers speculated that 3I Atlas might represent an entirely new class of object, interstellar relics, sculpted not by collision or chance, but by the forgotten mechanics of alien planetary systems. Others wondered if it was the universe's version of driftwood, debris cast off from stars long dead, shaped by forces we could scarcely imagine. In the cold silence of the data streams, there was an almost human quality to the search. Teams across continents worked in synchronization, not through command, but through instinct. They knew time was running short. Every interstellar visitor moved like a phantom through a corridor of opportunity. A few weeks to observe, a few months to analyze, then gone forever. Once 3I Atlas crossed beyond the reach of sunlight's reflection, it would vanish, a line of numbers on a graph, a ghost story told by photons. But even as its physical image faded, the legacy of its detection would remain. For the discovery of 3I Atlas was not just a triumph of technology, it was proof of evolution in perception. Humanity had built eyes capable of noticing what nature never meant to reveal. Through the harmony of optics, mathematics, and machine intelligence, it had pierced the quiet anonymity of the interstellar deep, and in that triumph lay something quietly profound. Each visitor that passed, each faint, impossible signal caught against the noise of the universe, was a reminder that we were not alone in the flow of matter and time. The cosmos was not a gallery of distant stars, but a living current. Rocks, dust, light, and perhaps intention, all drifting from one cradle of creation to another. 3I Atlas was part of that grand migration, a messenger from elsewhere. perhaps older than the sun itself. Yet beneath the scientific achievement, a whisper lingered, the same one that had haunted every astronomer since the first interstellar object was found. The realization that perhaps we were not discovering these visitors, but being introduced to them, that the watchers and the watched had, for the first time, met across the abyss. The next chapters of this story would dive deeper into that possibility, because soon the data from 3i Atlas would reveal something far more unsettling, not just about the object itself, but about the laws it refused to obey. In the sterile glow of late-night observatories, humanity's oldest emotion stirred once again, the uneasy harmony between wonder and doubt. Screens flickered with the light of data pulled from the farthest reaches of the sky. But behind every number lay something deeper, a quiet tremor in the foundations of certainty. The discovery of 3i Atlas had broken no laws outright, yet it strained them, bending equations until they shivered at their edges. The astronomers who watched its path were not merely measuring an orbit. They were standing at the fault line where science meets mystery. In the days following its confirmation as the third known interstellar object, the world's scientific community split in tone. NASA's official bulletins were cautious, polished in language, emphasizing natural explanations, an icy fragment perhaps, or a metallic core stripped bare by cosmic collisions. But beyond the press releases, among the forums, papers, and midnight discussions, something far less certain took root. Some scientists saw the strange acceleration data, the anomalous light curves, and whispered that perhaps, just perhaps, they were seeing the footprints of design at the Harvard-Smithsonian Center for Astrophysics. Avi Loeb's earlier theories about Oumuamua resurfaced like embers reignited. He had once proposed that the first interstellar object might have been a fragment of alien technology, a solar sail propelled not by chemistry but by light itself. His ideas were met with both fascination and resistance, sparking one of the most polarized debates in modern astronomy. Now, with 3i Atlas showing even more perplexing behavior, that debate re-emerged, sharper, louder, and far less dismissive. Was this object another natural wanderer, or evidence of something engineered on scales beyond comprehension? In meeting rooms across observatories and universities, the discussions grew tense. Equations were rewritten, simulations rerun, models broken and rebuilt. Each new attempt to explain the object's erratic acceleration seemed to demand the invention of new physics. A prospect both thrilling and terrifying. There were murmurs of magnetic propulsion through unknown materials, of interaction with interstellar plasma, of quantum forces at macroscopic scales. But all these explanations felt like guesses thrown into the dark. The data, pristine and merciless, refused to bend to theory, and then came the human element, the emotional fracture that always follows discovery. Some researchers began to lose sleep, unable to reconcile what they were seeing with what they had been taught. To admit the data's strangeness was to invite ridicule. To deny it was to betray curiosity. The conflict was almost spiritual. For centuries, science had been humanity's way of bringing order to the unknown. Yet here was something that looked back at that order and smiled, unbothered by its boundaries. In private interviews, some astronomers spoke candidly, their voices measured, but their eyes betraying unease. "It's not that we think it's artificial," one said. "It's that we can't prove it isn't." Others reminded their peers of the scientific creed. Extraordinary claims require extraordinary evidence. The tension hung in every conversation like static between frequencies. The desire to believe, clashing with the duty to doubt. History echoed through these moments. Galileo, forced to recant his observations under threat of exile, had once stared through a crude telescope and seen a universe that disobeyed church and scripture. Einstein, ridiculed for a theory that bent time itself, had persisted in the quiet conviction that beauty and truth could coexist in mathematics. Hawking, too, had faced skepticism when he dared to describe black holes not as cosmic voids, but as engines of information. Now, in the 21st century, a handful of scientists stood in their shadow, watching 3I Atlas dance against the fabric of the cosmos, and feeling the same pull between reason and revelation. Public fascination only deepened the divide. Social media, news networks, and documentaries began to speculate with reckless abandon, calling it the alien probe, the cosmic visitor, the artifact in motion. Every frame of data released to the public became fuel for wonder. And yet, within the scientific community, there was a quiet fatigue, a longing to find the truth without spectacle, to anchor the extraordinary in evidence rather than imagination. Still, the question lingered in every corner of discussion. What if imagination was necessary to reach truth? What if, in the vast unknown between stars, the act of believing, however tentatively, was itself a form of inquiry? As the object continued to defy models, one truth began to emerge. The greatest discoveries were not made in certainty, but in contradiction. When data defies belief, when instruments capture what logic rejects, science is forced to confront its own humility. The same humility that once made humanity lift its gaze to the stars now compelled it to question whether the universe it had so carefully charted might still be full of intention, of hidden architecture, of messages not yet deciphered. In that fragile space between disbelief and faith, 3I Atlas hovered like a mirror, reflecting not just light from another world, but the face of humanity itself, the face of a species that still dares to ask questions it cannot answer, the face of curiosity at war with its own fear. And as it drifted further into the void, still shimmering with unresolved data, one thought remained. Perhaps the greatest test of science is not discovery, but the courage to admit that the universe is still ahead of us, patiently waiting for our understanding to catch up. Outside the observatories, the world seemed oblivious to the tremor rippling through scientific circles. Yet, in the dim, humming silence of data rooms, where screens glowed with cosmic maps and orbital projections, that tremor was everything. Each new stream of measurements from 3I Atlas deepened the unease. Its brightness fluctuated in patterns that resisted randomness. Its trajectory curved ever so slightly against gravitational expectations, and its composition, inferred from spectral analysis, refused to fit neatly into any known category of asteroid or comet. For every hypothesis proposed, the object seemed to respond with quiet defiance. As though aware of being studied, some called it confirmation bias, others poetic illusion, but the effect was undeniable. The more data collected, the less sense it made. The human brain, wired for pattern and meaning, began to see intelligence where perhaps none existed. And yet, was that not the essence of discovery? The fragile tension between coincidence and intention, between the natural and the designed. In conferences streamed across continents, debates erupted over equations and interpretations. Physicists leaned on Occam's razor, insisting that the simplest explanation must be the correct one, that 3I Atlas was merely a peculiar shard of interstellar debris. But astrophysicists and planetary scientists pointed out its precision, the steadiness of its spin, the inexplicable stability in its energy profile, the faint suggestion of structure across its reflective surface. Nature, one researcher argued, rarely builds symmetry for no reason. Others countered that chaos often disguises itself as order, and that the cosmos thrives on deception. As nights grew longer and telescopes tracked its fading glow across the black, the human side of the story began to show. Graduate students watched their models collapse in real time, their predictions unraveling with every new dataset. Senior astronomers, veterans of countless failed anomalies, grew quieter, not dismissive, but thoughtful. Many remembered the lessons of history, the times when the impossible turned out to be real, and the real turned out to be misunderstood. From pulsars, mistaken for alien beacons, to cosmic microwave signals confused with microwave ovens. Science had been here before, standing on the brink of wonder, only to fall back into the arms of logic. Yet something about 3I Atlas felt different. It was not noise. It was not error. It was deliberate. In the solitude of those long observing sessions, there was beauty in the struggle. The act of questioning became almost sacred. To doubt was not to deny, but to honor the mystery. For some, this object symbolized the very heart of the scientific spirit, the willingness to admit ignorance in the presence of something vast. For others, it was a reminder that the line between science and philosophy had always been thinner than textbooks admit. A quiet melancholy settled over those who had devoted their lives to certainty. They began to realize that the laws they had spent decades mastering might be less like commandments, and more like translations, imperfect interpretations of a language. The universe has not yet finished teaching, and as 3I Atlas drifted beyond the reach of most instruments, disappearing once again into interstellar night, the conversation did not fade. It deepened. Papers continued to circulate. Theories continued to fracture. What remained was not a conclusion, but a haunting. The knowledge that discovery is not a moment of triumph, but of surrender. Because in the end, science is not about knowing everything. It is about standing in the silence of the unknown and listening carefully, humbly for whatever whispers back from the dark dot in the early hours before dawn. The telescopes were already awake, silent sentinels staring into the abyss, following a visitor that seemed older than the silence itself. 3I Atlas, now deep within the watchful gaze of humanity's instruments, revealed its secrets one spectrum at a time, faint, fractured, and impossible. Each wavelength carried a whisper of its composition, yet none aligned with any catalogued element known from asteroids, comets, or even exoplanetary debris. Its spectral signature shimmered with the ghostly traces of volatiles that should not exist in stable form, compounds that would disintegrate long before surviving such a journey through interstellar space. The data came in pulses, bright bands, then silence. When the numbers were stitched together, they told a story too strange for coincidence. The object's surface reflected light like polished alloy, yet radiated no heat. It shimmered without burning, glowed without warmth. Some theorists suggested it was coated in a layer of ultra-dense carbon or metallic hydrogen, compressed by eons of cosmic bombardment. Others argued the pattern resembled interference, as if light was interacting with a structured geometry, perhaps layers only nanometers thick, reminiscent of metamaterials engineered on Earth for stealth and reflectivity. Computational models traced its path backward through the galaxy, and what they found deepened the enigma. Its velocity and inclination suggested a birth far beyond the solar neighborhood, possibly from a red dwarf system nearly 300 light-years away, a region known for intense stellar winds and frequent flare activity. For such a fragile traveler to survive that origin, cross the turbulent sea of interstellar radiation, and emerge so pristine, it defied probability. Its surface bore no scars of time, no erosion by dust or cosmic rays, as though the universe itself had chosen to preserve it. Radar pings were sent from Goldstone and Arecibo before its departure grew to distant. None returned as expected. The signals scattered unpredictably, absorbed or refracted in ways no natural body should manage. It was not simply silent, it was evasive, as if built to remain unseen. Scientists, cautious but restless, turned to laser ranging. Even those reflections came back warped, delayed by milliseconds, suggesting strange interference patterns. Some whispered of hollow cavities, of internal geometry that bent light itself, yet the evidence, though tantalizing, refused to resolve into certainty. Theoretical astrophysicists began to chase explanations that once belonged to science fiction. Could a natural process form a body with such optical behavior, a frozen lattice of plasma dust, perhaps shaped by electromagnetic storms near dying stars? Or was it something older, a relic of processes that predate even stellar evolution as understood? Every simulation failed, every attempt to match its albedo spin and density contradicted the laws that defined known matter. In the supercomputing centers of NASA, Ames and the European Southern Observatory, artificial intelligence models were tasked with reconstructing its possible form. The results were uncanny, elongated, yet irregular, shaped like something between a spindle and a shell, its density varying as if hollow in places. The models never converged to one definitive solution. Each run produced slight deviations, as though the object resisted being defined, shifting subtly between interpretations. And so began the uneasy silence, not of absence, but of wonder. The deeper the analysis went, the more elusive truth became. Instruments designed to measure certainty were met with ambiguity. Nature, usually a patient teacher, seemed this time reluctant to answer. What the universe had sent was not a clue, but a mirror, one that reflected back not the object's origin, but humanity's hunger to understand. In that growing silence, as 3I Atlas slipped further into the black, a realization began to take hold among those watching. Perhaps some mysteries are not meant to be solved at once. Perhaps they exist to slow our certainty, to remind us that every equation, no matter how elegant, is still a translation of something far older and infinitely more complex. For in chasing 3I Atlas across the void, humanity was not just studying a distant traveler, it was staring into the unfinished language of the cosmos itself. Weeks turned into months, and 3I Atlas continued its silent passage through the inner solar system. The more instruments fixed their gaze upon it, the more it seemed to blur the line between physical object and cosmic illusion. Its brightness fluctuated, as if pulsing to some distant rhythm, a faint heartbeat echoing across the void. The periodic changes were not random. They followed no cometary outgassing pattern, no predictable spin. Instead, the light curve hinted at a hidden order, a cycle too precise to be explained by natural tumbling. Infrared sensors aboard NASA's NEO-EYES telescope registered something even stranger. The object emitted almost no thermal radiation. Despite its proximity to the sun, even a frozen body of ice and rock would warm slightly and re-radiate heat into space. 3I Atlas did not. Its energy balance broke every thermal model applied to it. It reflected sunlight without absorbing it, as though its surface were designed to repel energy altogether. The result puzzled thermal physicists. How could something interact with light yet remain untouched by it? Meanwhile, polarization studies from the European Southern Observatory in Chile detected a faint but consistent alignment of reflected light. Waves, a telltale sign of structure at a microscopic level. In normal comets, such polarization occurs randomly, diffused by dust grains. But here, it appeared ordered, as though light was glancing off parallel layers, thin, uniform, and deliberate. Some speculated it could be a crystalline composite formed under intense cosmic radiation. Others whispered of engineered nanostructures designed to manipulate light itself. Both explanations seemed equally implausible, yet neither could be dismissed. In laboratories and observatories around the world, sleepless scientists stared at flickering screens filled with cascading data streams. Algorithms processed the readings, searching for periodicities, rotational harmonics, any pattern that might bring coherence to the chaos. None found an answer. The object's motion, too, betrayed anomalies, subtle drifts inconsistent with the sun's gravity or solar pressure. It was as though invisible hands adjusted its trajectory, nudging it slightly away from predicted paths. Resisting the pull of celestial mechanics, conversations grew tense. To some, it was merely a statistical outlier, a cosmic rock that refused easy categorization. To others, it was something far more profound, a whisper from beyond that defied coincidence. Private communications between observatories revealed what official statements did not. Several teams had recorded unexpected signal distortions whenever their instruments locked onto 3I Atlas. The data streams, though faint, carried repeating noise patterns, almost rhythmic, a modulated pulse buried within cosmic background interference. Most dismissed it as an artifact of equipment calibration. A few, however, quietly archived the anomaly, unwilling to delete what they could not yet explain. In the public eye, the story had already transcended science. Headlines spoke of alien relics, cosmic probes, and messages from the deep. Scientists recoiled at such sensationalism, yet privately, many felt the same stirring of unease. The evidence was incomplete, but it refused to conform. Nature, in all its elegance, was supposed to be consistent, predictable, measurable. 3I Atlas was not. As its distance grew, the opportunity for observation waned. The window was closing fast. The visitor would soon slip beyond reach, vanishing into the same darkness from which it came. Still, the data collected would haunt the scientific community for decades to come. For every theory proposed, a dozen new contradictions appeared. In that failure to explain, something remarkable happened. The boundaries of certainty began to dissolve. In a world driven by equations and definitions, 3I Atlas became a symbol of the unknown, not as a limitation, but as a reminder that beyond the reach of even the most advanced instruments, there still exists a frontier where the laws of physics tremble, and where imagination becomes the only compass left. For in its silence, the object spoke a truth older than science itself, that discovery is not the end of mystery, but its beginning in the fading glow of late observation. 3I Atlas drifted beyond the range of most telescopes, yet the debate it ignited only grew brighter. Across continents, in quiet observatories and dimly lit offices, scientists wrestled with the realization that what they were seeing no longer fit within the latticework of known physics. The equations that once described the universe so faithfully began to fray at their edges. Constants appeared less constant. Patterns, once solid, dissolved into probabilities. It was as though the cosmos itself were whispering that its truths were conditional, temporary reflections of a deeper, shifting reality. At the heart of this reckoning stood the object itself, suspended between comprehension and myth. Its motion still haunted models, a subtle variance in deceleration, small yet undeniable. It did not lose momentum as expected when leaving the gravitational influence of the sun. Instead, it seemed to glide with a strange efficiency, as though space around it offered less resistance, or time flowed differently along its path. Astrophysicists attempted to simulate the phenomenon using relativistic models of space-time curvature, and yet none could recreate the subtle anomalies that telescopes recorded. Some suggested that the object might be interacting with the geometry of space-time, directly bending, not through mass, but through a manipulation of the vacuum fabric itself. The idea sounded impossible, yet it lingered in the corridors of theory. Could 3I Atlas be enveloped in a form of exotic field, a bubble of altered space-time? Quantum physicists, revisiting models of vacuum energy and Casimir effects, speculated whether certain configurations of material could suppress inertia or redirect radiation pressure. The implications were staggering. An interstellar object, naturally or otherwise, capable of modifying how it moved through the universe, not by propulsion, but by negotiation with the fabric of existence. Others proposed an even stranger explanation. Perhaps, they argued, what humanity was seeing was not a solid body at all, but a kind of gravitational lensing artifact, the visible echo of a massless structure, refracting light across distances too vast to comprehend. If so, 3I Atlas might not even exist as matter, but as a pattern, a ripple cast from an unseen source beyond the reach of any telescope. In this view, the object was less a visitor and more a message, a byproduct of space-time itself, reflecting the unseen architectures of the cosmos. For those unwilling to abandon conventional physics, alternative possibilities took shape. Some speculated it could be composed of exotic matter, baryon-poor material, perhaps dark matter, granules, bound into transient form by ancient gravitational events. Others likened it to a relic, a piece of technology so old that even its purpose had been erased by eons of travel. The comparison with humanity's own Voyager probes was impossible to ignore. Those small, silent messengers, too, were now drifting between the stars, their signals weakening, their paths uncertain. In a million years, they might appear much like this, faint, anomalous, misunderstood. Could 3I Atlas be someone else's Voyager, adrift in a sea of galaxies long after its makers were gone? And yet, even among the boldest theories, one truth remained. Every calculation, every spectral reading, every dataset agreed on one thing. The object violated conservation expectations at an interstellar scale. It did not behave like matter bound by gravity or radiation. The more they refined their models, the clearer it became that it was not energy they were losing, it was understanding itself. The universe, it seemed, was pulling back the curtain, revealing that what humanity had called laws were only the outlines of something far deeper, far less certain. In late-night symposiums and closed conferences, the conversations grew philosophical. What if science was never meant to be a perfect mirror of the cosmos, but merely its translation, imperfect, evolving, human? The equations that once described stars and planets now met something that refused description, an entity that answered not to predictability, but to mystery. Perhaps, they wondered, this was not an anomaly at all, but a reminder that knowledge and humility are bound together in the same orbit as 3I. Atlas faded into the distant dark. The instruments continued to hum, still tracking, still listening. But now there was silence, not of defeat, but of reverence. The kind that follows the realization that the universe may not be a riddle to solve, but a conversation to be continued. The story of 3I Atlas did not end with answers. It ended with a mirror held up to the human mind, reflecting its longing, its limits, and its unyielding desire to know what waits beyond the edge of reason. In the stillness that followed its retreat, the silence around 3I Atlas became louder than the data itself. The object had slipped beyond the reach of most instruments, vanishing into the black sea between the planets. Yet its echo persisted in equations rewritten, in sleepless discussions, in the uneasy awe that filled the hearts of those who had seen its trace. For scientists, it was no longer about the object alone. It was about what it revealed, that even at the height of understanding, reality can still shift beneath human feet. Inside observatories, simulation screens flickered with attempts to recreate what had been witnessed. Models of gravitational interactions, light reflection, and energy dispersion sprawled across arrays of code, each iteration striving for coherence, each failure tightening the mystery. The object's reflective spectrum contained ratios of metallic elements not naturally combined, and its energy retention over distance appeared almost deliberate. The idea of something engineered no longer felt taboo, though none dared speak it as fact. An artifact until proven otherwise, one researcher wrote, and proof may take longer than the object's return. As months passed, new theories ventured further from the edge of known science. Some proposed that 3I Atlas could be an ancient probe powered by mechanisms lost to cosmic time, a machine that harvested energy not through fusion or radiation, but through quantum fluctuations in the vacuum. Others imagined a natural explanation just as strange, a remnant of a star system torn apart by gravitational tides, its atomic structure frozen and reconfigured under pressures unknown to local physics. Either possibility carried the same implication, that the universe was capable of constructing matter and motion in ways still invisible to human comprehension. Across disciplines, the language of discussion began to change. Physicists spoke of phase, coherence, energy, dissipation, asymmetry, and vacuum resonance, terms once reserved for abstract theory, now applied to something real. Cosmologists wondered if 3I Atlas had passed through regions of distorted space-time, collecting the imprint of gravitational anomalies like a traveler collecting scars. Others speculated that it had simply existed too long, too far, for human physics to still apply, that the laws known to Earth might be local dialects of a greater universal language, one whose grammar shifted across the stars. In the background of all this theorizing, a quieter narrative unfolded, the human reckoning with insignificance. For generations, scientists had built frameworks that gave the cosmos a sense of order, a rhythm of predictability. But now, standing before something that rejected all categories, they felt the weight of humility return. Not defeat, but wonder, that ancient feeling once known to those who looked up at the night sky and felt small in a universe too vast to map. There was an almost spiritual undertone to the discussions that followed. Some called 3I Atlas a cosmic mirror, not because it reflected light, but because it reflected humanity's own limitations. The more it was studied, the more it revealed how much of science was built not on answers, but on approximations, the best guesses in a universe that allows only glimpses of its truth. And yet, that limitation was not despair. It was beauty, because it meant that discovery was endless, that even in the age of advanced telescopes and quantum models, mystery still existed, breathing quietly beyond the last pixel of a digital image. In the end, what 3I Atlas left behind was not data, but perspective. It forced a confrontation with the fragility of understanding, the reminder that human perception, bound by 3 dimensions and linear time, may never see the full architecture of reality. Still, the pursuit continues, because that is what it means to be human, to reach for meaning in a cosmos that may never answer, and to find, within that silence, a kind of faith, not in certainty, but in the search itself. And so, even as the object drifted farther into darkness, astronomers continued to trace its projected path, extending lines of possibility into the unknown. Somewhere, billions of kilometers away, 3I Atlas carried on, indifferent, ancient, and silent. Yet in that silence, it had already changed something profound. It reminded the species watching from a small blue world that the edge of science is not the boundary of knowledge, but the beginning of imagination, and that the universe, in its infinite patience, is still teaching what it means to understand. The pursuit of explanation began with familiar tools: mathematics, modeling, and reason, the same instruments that had tamed comets, decoded pulsars, and mapped the hidden geometry of space-time. To understand 3I Atlas, scientists first turned to what had always guided them, the laws that defined celestial motion. Yet this time, those laws seemed to hesitate, as if unsure of their own authority. The first dominant interpretation emerged quickly: the fragment theory. Perhaps, it was proposed, 3I Atlas was a shard, a remnant torn from a shattered exoplanet orbiting a distant, dying star. This would explain its strange irregularity, the asymmetrical spin, the erratic brightness, the faint metallic hints in its spectral signature. Debris fields born of destruction often carry chaos in their motion, a chaos that could easily be mistaken for anomaly. Simulations traced its hypothetical path backward through time, suggesting it might have been expelled from a red dwarf system hundreds of light-years away, its velocity amplified by the gravitational slingshot of another world's death. Yet even this elegant narrative faltered under scrutiny. For a fragment so ancient, its surface looked new, smooth, reflective, strangely intact. No cosmic sandblasting, no erosion from countless micrometeorite impacts. It had crossed the galaxy as though time itself had spared it. Others turned toward the familiar case of Oumuamua, the first interstellar object ever recorded. In that mysterious traveler, they found echoes of explanation: radiation pressure. Perhaps 3I Atlas, too, was being pushed not by engines, not by intention, but by the faint breath of starlight. This non-gravitational acceleration, they argued, could result from sublimation, jets of vapor expelled from hidden ices beneath its surface, invisible to human instruments. The mathematics worked, almost, but no trace of outgassing appeared in the infrared scans. No emission signatures, no dust tail. It was moving as though driven by a force that left no fingerprint. From there, the conversation turned toward composition. The porous ice hypothesis gained traction, a theory that 3I Atlas could be made of exotic molecular ice, a lattice so delicate that sunlight itself could nudge it forward. Under solar heating, such material would create acceleration patterns mimicking deliberate propulsion. Researchers at the Harvard-Smithsonian Center and the Max Planck Institute tested this idea with experimental ice analogues, confirming that light could indeed drive microfragments through subtle radiation coupling. But the mass of 3I Atlas was too great, the effect too small. The numbers refused to agree. As the months passed, alternative refinements grew increasingly creative. Some suggested that impacts with interstellar dust might have altered its spin, collisions so tiny, so spread across time, that they would seem spontaneous. Others proposed that a recent gravitational encounter with a rogue planet or brown dwarf could have redefined its path. Planetary modelers mapped potential systems it might have originated from, focusing on red dwarf clusters and binary stars. Perhaps, they reasoned, it was ejected during the collapse of a planetary orbit, a fragment cast adrift when a world was torn apart by tidal forces. Each simulation added pieces to a puzzle that refused completion. The scientific world wrestled with contradictions. Peer-reviewed papers contradicted one another in tone and in certainty. Some called it the product of exotic astrophysics, others of statistical illusion. The European Southern Observatory released a cautious statement. 3I Atlas remains a natural body under investigation. Yet in the margins of research notes and the quiet corners of late-night conferences, whispers spread. Because despite every model, every recalibrated dataset, every refined hypothesis, one observation endured. 3I Atlas did not merely move with the solar wind. It moved against it. This single fact unsettled even the most grounded minds. Radiation pressure should have slowed it. Instead, it seemed to respond to sunlight with an inverted logic, as though its relationship with energy operated backward. A comet sheds mass and slows. The first atlas shimmered and accelerated. The effect was small but precise, measurable beyond statistical doubt. It broke the rulebook not by chaos, but by consistency, the most dangerous kind of defiance. And so the mainstream explanations, though sophisticated, began to sound like apologies, beautiful constructs built to preserve a sense of order. Yet beneath the calm professionalism of published language lay the quiet tremor of doubt. Because every natural model, no matter how elaborate, carried within it a question that would not go away. What if the anomaly is not in the data, but in our assumptions about reality itself? In that unspoken question, science brushed against the edge of faith, not in the spiritual sense, but in the belief that the universe, however complex, must still obey its own rules. 3I Atlas was testing that belief, inch by inch, orbit by orbit, and as the object continued its silent departure into the dark, the astronomers left behind were forced to face a truth as humbling as it was thrilling, that the line between explanation and wonder is thinner than ever, and perhaps it was never meant to hold gradually. The tone of inquiry began to shift. What had started as a confident campaign to categorize 3I Atlas became something quieter, almost reverent. The familiar rhythm of science observe, model, verify was beginning to sound uncertain, like a song played on unfamiliar strings. Every new analysis deepened the mystery instead of dissolving it. Instruments designed to reveal truth were instead amplifying contradiction. Each reading seemed to describe not one object, but several superimposed possibilities. At the European Space Agency's data archives, teams revisited the early light curves, searching for flaws. Could cosmic rays, calibration errors, or atmospheric distortions have created illusions in the photometry? The results came back clean. The anomalies persisted. Its albedo fluctuated as if its surface was not reflecting sunlight, but refracting it, twisting the incoming light in patterns unlike any known material. When modeled through spectrographic filters, the reflection curve resembled that of composite structures, thin-layered materials with alternating densities. Such patterns were found in engineered metamaterials, not in natural rock or ice. Still, no one dared to suggest design. To imply intention was to cross a line few wished to approach. NASA's Deep Space Network tracked its subtle acceleration long after most comets would have faded from detection. As the data streamed in, a disquieting symmetry appeared. The thrust was not random. It pulsed faintly in relation to its rotation period, as though responding to an internal rhythm. The signal was faint, buried within noise, but when enhanced, the curve repeated with mathematical precision. It could still be coincidence, a product of physics we had yet to understand, but coincidences that repeated this cleanly began to feel like messages, written in the fabric of motion itself. Meanwhile, the debate expanded beyond astronomy. Physicists entered the discussion, proposing that 3I Atlas might demonstrate interactions between baryonic matter and dark sector particles, an unknown mechanism producing apparent thrust without any. Some cited early hypotheses of dark drag, where invisible fields could exchange momentum under rare conditions. Others invoked modified Newtonian dynamics or local distortions of the metric field. Such ideas once lived only in the abstract corners of theoretical journals, but 3I Atlas gave them shape, form, and urgency. It was not just a rock from another star system. It was a test case for the boundaries of the known universe. Peer review became battleground. One camp argued for restraint, warning that extraordinary claims demand extraordinary evidence. Another insisted that clinging to convention was itself unscientific. If we explain everything with what we already know, one researcher wrote, then discovery ceases to exist. This tension between skepticism and wonder echoed the history of science itself. Every great revelation had once sounded impossible, yet impossibility is only a measure of imagination's limits, not nature's. As 3I Atlas continued its silent voyage outward, crossing beyond Mars's orbit, its faint optical trail dimmed but did not vanish. Telescopes still caught glimmers from its rotating sides, each flicker a heartbeat of cosmic enigma. In those pulses, some saw data, others saw poetry. All saw the reminder that humanity's understanding of the universe is provisional, a temporary truce between curiosity and chaos, and in that realization, science stood at a precipice, gazing into its own reflection. The search for 3I Atlas had become more than the pursuit of a celestial body. It was a confrontation with the boundaries of knowledge itself, moment where reason looked into the unknown and recognized, with both awe and humility, that perhaps the unknown was looking back in the shadowed corridors of science. Where evidence fades into wonder, imagination becomes the last surviving tool. When numbers begin to tremble and equations hesitate to converge, minds reach toward the unthinkable, for sometimes what cannot be measured must still be explored. 3I Atlas had become such a frontier, not just for astronomy, but for thought itself. To some, it was an echo of Oumuamua's defiance, a continuation of that first whisper from the stars. To others, it was something deeper, a deliberate sign cast across interstellar space like a message in motion. Among the most daring voices stood Avi Loeb's solar sail hypothesis, reborn in a new light. Perhaps, he proposed, the object's unusual acceleration was not born of ice or gas, but of design, a wafer-thin structure, propelled by starlight, wandering through the galaxy as debris of a civilization older than imagination, a relic not of intention, but of endurance. If so, it would mean that 3I Atlas was not merely visiting, it was surviving, carrying within it the physical grammar of technologies that transcend our comprehension. Critics countered with caution, grounding the conversation in thermodynamics and radiation pressure, yet the allure of purpose shimmered between the lines. After all, every law once called unbreakable had eventually bent to discovery. The self-stabilizing relic theory soon followed, a concept that suggested a form of matter unknown to chemistry or crystal, engineered to maintain trajectory through adaptive response, a material that learns from the forces acting upon it. Its rotation, oddly steady despite external perturbations, fueled the notion that something about it resisted decay, like an organism holding shape against entropy. Some researchers pointed to emergent material sciences on Earth, graphene lattice, self-healing polymers, photonic metamaterials, and wondered if what humanity was only beginning to invent had already existed elsewhere for eons. Then came a bolder speculation that 3I Atlas might not be a relic at all, but a messenger. The interstellar beacon idea took form not in data, but in philosophy. Perhaps such objects were not meant to transmit signals, but to provoke them to seed thought, to awaken the minds of young civilizations by forcing them to confront what they cannot explain. A question disguised as stone, a cosmic mirror held to the curiosity of sentient life. After all, if the purpose of intelligence is to seek meaning, then perhaps the universe communicates best through mystery. Others turned their gaze inward, not to the stars, but to the structure of reality itself. The simulation hypothesis found its place in the discourse, whispered between equations and ethics. What if the anomalies were not in the object, but in the program that renders it? A computational boundary where precision falters, revealing the scaffolding beneath existence. In that view, 3i Atlas was not a traveler, but a glitch, a visible seam in the code of the cosmos. If so, its defiance of physics was not proof of alien technology, but evidence that the universe itself is an algorithm struggling to sustain its own illusion. And deeper still, beneath mathematics and machinery, lingered the poetic theory of the quantum scar. It proposed that space-time might carry memory, that the fabric of reality can retain imprints of what once moved through it, like ripples frozen in the ocean of time. If true, then 3i Atlas could be not a solid object at all, but a relic trajectory, a fossilized motion encoded within the quantum field, an echo of a civilization long gone. Not matter, but memory. Yet, for all the speculation, even the cold precision of artificial intelligence faltered. Neural networks trained on thousands of trajectories could not reproduce its path. The algorithms, designed to see what humans cannot, reported an error, as though the motion of 3i Atlas existed in a mathematical dialect beyond our comprehension. Its course through the solar system felt less like movement and more like intent. It did not fall, drift, or accelerate. It behaved as though it knew where it was going. And so, the silence around it deepened. Observatories dimmed their lights, their lenses turning toward other skies. The object continued on its way, vanishing into the cold ocean of interstellar night. But its question remained, hovering in the consciousness of those who had dared to study it. What if this was not an object at all? What if it was a language, written not in words, but in the laws of motion themselves? For perhaps, in the end, humanity was never meant to catch it, only to notice it, to see, if only for a moment, that the universe is capable of poetry, and that sometimes the poet is not us. As weeks turned to months, the echo of 3i Atlas refused to fade. The scientific community, though weary, could not turn away. Each dataset, each faint streak of light, still archived in observatory records, became a relic of inquiry, fragments of something larger, something unsolved. In laboratories across the world, researchers dissected the silence it had left behind. If its passage was a sentence, they hoped to uncover its grammar. Spectral fingerprints were reanalyzed with unprecedented precision, every photon measured as though it contained a clue. The signal-to-noise ratios told a quiet story. There were no outgassing trails, no predictable thermal emissions, no radiation spikes expected from a fragment under solar influence. Instead, what remained was a puzzle suspended between presence and absence, an object that interacted with reality yet left no trace of cause. It was here, in this liminal space between knowledge and uncertainty, that science began to mirror philosophy. Discussions once confined to conferences spilled into public forums. Astronomers spoke cautiously of non-classical motion. Physicists invoked terms like local curvature variance, trying to quantify the unquantifiable. Even theologians and poets entered the dialogue, suggesting that perhaps 3i Atlas was neither random nor mechanical, but symbolic, The object had become a crossroads where mathematics met meaning, and human curiosity stood trembling before its own reflection. One emerging model suggested that the object might exploit an overlooked loophole in spacetime itself. Theoretical physicists revisited older papers on gravitational tunneling and vacuum fluctuations, imagining that certain configurations of exotic matter could distort their inertial reference frames, allowing movement without propulsion. If 3I Atlas contained such material, even in trace quantities, it might explain the faint but measurable accelerations defying solar and gravitational predictions. But this idea teetered on the edge of speculation. There was no known process to create such matter, no reason it should exist naturally, and yet nature had surprised humanity before. Parallel to these calculations, another hypothesis grew quietly in the corners of late-night meetings and encrypted messages. What if 3I Atlas was observing us in return? The idea was not one of sentience in the human sense, but of feedback, that its trajectory subtly adjusted in response to being tracked. Quantum mechanics had already blurred the boundaries between observation and behavior at microscopic scales. What if that principle extended outward, woven through the architecture of the cosmos? What if observation itself, when directed toward something beyond comprehension, changed both the observer and the observed? The more scientists tried to measure, the more elusive the answers became. Some likened it to chasing a mirage. The harder they looked, the more it shifted. Others compared it to the behavior of quantum systems under decoherence. Knowledge seemed to collapse the mystery rather than solve it. This paradox sparked a haunting idea. Perhaps 3I Atlas was not a visitor from elsewhere, but a reflection of our own limitations. An interstellar mirror revealing the boundaries of human perception. In this quiet confusion, history repeated itself. Just as ancient astronomers once mistook comets for omens, the modern era faced its own version of celestial doubt. But unlike those early watchers, humanity now had instruments powerful enough to expose its ignorance in exquisite detail. Telescopes capable of capturing photons across millions of kilometers showed not answers, but more questions. The object's brightness fluctuated with a rhythm almost deliberate, pulses separated by irregular intervals, like an untranslatable code. Whether this was coincidence or intention, no one could say. And so, the debate endured between those who sought comfort in the laws of physics, and those who sensed those laws bending under the weight of the unknown. Theories branched into two forests, one of reason, one of wonder. Somewhere between them, truth waited in silence, because 3I Atlas had already achieved what few discoveries ever could. It reminded a species that even with its instruments aimed at infinity, it was still searching within itself. As the last confirmed observation faded from view, a strange calm followed. The stars reclaimed their familiar order, but something fundamental had shifted in the minds of those who had looked too closely. The universe had revealed, once again, that it does not owe explanation, only existence. And perhaps that was the message all along, that the greatest signal from beyond might not come in radio waves or light, but in the silence that compels us to keep asking. As 3I Atlas receded beyond the sun's glare, the silence it left behind was not emptiness, but resonance, a hum that carried through observatories, universities, and late-night control rooms across the planet. The object, now too distant for direct imaging, lingered as a ghost in data streams, its final light curves whispering across radio spectrums and photon counts. Humanity, unwilling to let go, began its most ambitious pursuit yet, not through telescopes, but through collaboration. Across continents, servers linked and satellites shared, as NASA, the European Southern Observatory, and the SETI Institute pooled their archives into a single, expanding dataset. What once was a fleeting streak on a sensor became a shared mystery uniting thousands of minds. The James Webb Space Telescope, in its final attempt before the object slipped into the veil of cosmic background, captured images of startling beauty. In infrared 3I Atlas shimmered faintly against the tapestry of stars, its shape indistinct, its glow uneven, as if reflecting light from within rather than without. The Hubble's final optical frames showed the same enigma, a speck of defiance against the darkness. Neither comet nor asteroid, a fragment of something unclear. Scientists compared both datasets, mapping spectral lines, polarization patterns, and reflectivity ratios, each detail a clue that only deepened the mystery. The light behaved as though filtered through unknown material, bending slightly off expected wavelengths, whispering of structures finer than atomic lattice. Supercomputers took over where telescopes could not. Vast simulations were run, tracing trajectories across millions of years, back through galactic arms and gravitational tides. Models placed its origin near red dwarfs, binary systems, even rogue planetary belts, but none fit perfectly. The numbers rebelled. Every calculation left a residue of anomaly, a deviation too precise to dismiss, yet too small to explain. Machine learning algorithms, designed to replicate orbital behavior, failed to capture the subtleties of its motion. It was as though 3I Atlas had been written by a different hand of physics, one whose syntax Earth's equations had not yet learned to read. Meanwhile, the dreamers began to plan what might come next. Aerospace agencies and private ventures, emboldened by the discovery, drafted blueprints for intercept missions, autonomous probes, capable of chasing the next interstellar visitor before it slipped away. Concepts like the Comet Interceptor, once hypothetical, now felt urgent. If 3I Atlas had taught humanity anything, it was the cost of delay. The next time an object from beyond crossed the solar boundary, there would be no hesitation. Engines would ignite, trajectories would align, and humanity would finally meet such a traveler face to face. The idea was no longer science fiction. It was strategy. Yet, beneath the hum of ambition, a deeper reflection stirred. The more the data accumulated, the more fragile certainty became. What began as a scientific puzzle had evolved into something existential, a mirror held against civilization itself. In the depths of observation, humans saw their own hunger for meaning reflected in the cosmos. The paradox of progress unfolded in quiet irony. Every discovery widened the circle of the unknown. Knowledge no longer felt like a conquest, but a horizon that retreated as quickly as it was approached. In quiet moments between measurements and meetings, astronomers found themselves staring at the same stars through which 3I Atlas had vanished. They understood now that they were not merely watching space, they were part of its unfolding. The object had passed, but its echo remained in the instruments it inspired, the debates it provoked, and the humility it restored. It had shown that the universe is not static but alive with riddles, each one shaped to remind its observers that certainty is fleeting. But curiosity endures. As data faded into background noise and the object's coordinates slipped beyond reach, a calm acceptance settled in. 3I Atlas had crossed their sky like a thought, brief, brilliant, transformative. The telescopes turned elsewhere, but something unseen had changed within their operators. Humanity had not solved the mystery, but had discovered something more profound, that the act of wondering is its own kind of contact. And so, as the faint traveler disappeared into the vastness between stars, the pursuit did not end, it only shifted inward. In the quiet afterglow of discovery, Earth stood beneath its ancient sky, small yet unyielding, realizing that to seek understanding in a universe of enigmas is not futility, but identity. For 3i Atlas was never just a visitor from beyond. It was a reminder that the cosmos still dreams through us, and that curiosity, once awakened, is the one force that refuses to fade into the dark. In the aftermath of its departure, what remained was not an absence, but a gravity of thought, an invisible field pulling the collective imagination of humankind toward questions larger than itself. Astronomers who once spoke in the language of mass, orbit, and magnitude now found themselves invoking metaphors of memory and intent. It was as if 3i Atlas had not simply passed through the solar system, but through the psyche of the species observing it. Every archived photon, every calibration log became sacred, a record of the moment when the universe looked back and asked to be understood differently. New instruments were proposed, not merely more powerful, but more perceptive. The Verisi-Rubin Observatory, nearing completion, became a symbol of this renewed vigilance, a machine built to never miss another interstellar whisper. Its wide-field survey, capable of mapping the entire visible sky every few nights, promised to catch the next traveler long before it arrived. But even as engineers perfected optics and algorithms, theorists wrestled with the deeper implication that 3i Atlas may have revealed that the universe is not just a stage of matter, but a dynamic conversation between the known and the unknowable. Across think tanks and observatories, the dialogue shifted from what was it to what are we missing. Some physicists suggested the object might hint at a yet undiscovered layer of interaction, a faint coupling between light and gravity, or perhaps a relic of an era when the laws of physics were still forming. The notion seemed radical, yet comforting, that the cosmos could still surprise, still harbor secrets older than time's own symmetry. Papers emerged proposing new constants, revised models of interstellar drift, even frameworks where quantum entanglement could influence macro-orbital motion. None could yet be tested, but all carried the same undercurrent. The 3i Atlas had expanded the boundaries of legitimate wonder. SETI's archives, long dominated by the search for artificial signals, began to reinterpret their silence. What if intelligence, they asked, was not limited to radio frequencies or chemical signatures, but existed in the very architectures of motion? Could something be communicating not through sound or code, but through behavior, through defiance of prediction itself? The idea was speculative, even poetic, but it resonated, because in its unpredictable flight, 3i Atlas had behaved as if guided by purpose, not necessarily consciousness, but something equally profound, persistence, a will to move through the interstellar dark, indifferent to comprehension yet irresistible to curiosity. Amidst this new frontier of thought, artists, philosophers, and poets joined the conversation. Museums began to display composite images of the object, juxtaposed with words about distance, impermanence, and time. The boundaries between science and art blurred, both reaching toward the same ineffable thing. 3i Atlas had become not merely an astronomical event, but a cultural myth in the making, one that spoke to a truth long forgotten, that mystery is not an obstacle to knowledge, but its lifeblood. The next generation of scientists, still in their early years of study, looked upon those archival images with reverence. To them, it represented a turning point, the moment humanity stopped assuming the cosmos was fully charted. They studied with a quiet conviction that someday, perhaps decades from now, a new interstellar visitor would appear, and when it did, Earth would be ready, not just technologically, but philosophically. ready to see not just an object, but a message carved in motion. As the echoes of 3i Atlas faded from instruments and headlines, its influence deepened in ways unseen. Research funding shifted toward interstellar exploration. Interdisciplinary collaborations flourished, and the very definition of astronomy evolved. No longer confined to the observation of stars and planets, it became the study of cosmic behavior, the search for the universe's intent, and beneath the vast night sky, where photons from the distant traveler still faintly crossed the void, a truth began to crystallize, that humanity had glimpsed the outer edge of its own comprehension. The stars no longer looked silent, they seemed to breathe. The cosmos, once indifferent, now appeared intimate, a mirror reflecting the same restless urge that drives atoms to bond, galaxies to spin, and civilizations to ask why. In the faint afterglow of 3i Atlas's passing, science found something far rarer than certainty, a sense of belonging in the unknown. The mystery had not been solved nor tamed. It had simply moved on, leaving behind an awakened species gazing upward, knowing that somewhere in the boundless dark, the impossible still travels. It drifts now beyond every instrument, past the reach of photons and the patience of machines, a fragment of light swallowed by the slow infinity of space. 3i Atlas, once a glimmer on human screens, now belongs entirely to the unknown. No telescope can follow its path anymore. No equation can trace its truth. It travels alone through the silence between stars, a wanderer untouched by the limits of comprehension, and yet, somehow, still bound to the species that once glimpsed it and dared to ask why. In the archives of Earth, its memory persists. Spectral graphs, pixelated frames, columns of numbers, all that remains of something that may have been more than physics, or perhaps simply physics in a form too subtle to decode. The data is still analyzed, still debated, but what endures beyond the mathematics is the feeling, the unspoken awe that science rarely admits aloud, that for all its precision, knowledge is a fragile light, flickering against the vast and eternal dark. Humanity, in its relentless curiosity, projected its own reflection into that object. Some saw technology, others nature, a few glimpsed something sacred. Yet beneath every interpretation lay the same quiet truth, that in searching for intelligence among the stars, we are really searching for a reflection of our own. The mystery of 3i Atlas was never only about what it was, but what it revealed about those who observed it. Every calculation, every sleepless night at an observatory, every speculative theory whispered into the void was, in essence, an act of hope. Hope that the universe might acknowledge our question, even if it never answers. As the object fades, so too does the illusion of certainty. Science, the great architecture of reason, finds itself standing once again at the edge of mystery, humbled but unbroken. In its quietest moments, even the most rational minds know that discovery is not the opposite of faith, but its continuation. To seek the unknown is to believe that meaning exists somewhere, hidden within the vastness. To explore is to trust that understanding, however fleeting, is worth the uncertainty it demands. Perhaps these interstellar travelers are not visitors at all, but reminders, subtle cosmic messengers teaching us to measure our existence, not in what we know, but in how deeply we are willing to wonder. For every object that slips away into darkness, countless others remain unseen, waiting. The universe is not withholding. It is simply infinite. Its silence is not rejection, but invitation, a canvas vast enough to hold every human question without ever reaching an end. In the end, 3i Atlas becomes more than an astronomical anomaly. It becomes a parable of curiosity, a reflection of the human condition itself. Fragile beings on a pale world, building instruments to chase fragments of light across time, driven by nothing more than the need to understand why there is something rather than nothing. The longing is our gravity. It holds us to the stars as surely as planets hold to their suns, far beyond our reach. The traveler continues, silent and indifferent. Yet within that indifference lies a quiet beauty. The universe does not need to speak for us to listen. Its mystery is not a wall, but a mirror, one that reflects a civilization awakening to the realization that perhaps it is the anomaly, the fleeting spark trying to make sense of eternity. And so, as the final trace of 3i Atlas dissolves into the black, what remains is not the loss of understanding, but the deep serenity of perspective. The cosmos owes no answers. It offers wonder instead, and that is enough, for wonder is the first language of intelligence, the bridge between knowledge and the unknown. Somewhere in that boundless silence, another fragment may already be on its way. Another story, another question, another chance to see ourselves reflected in the stars. Until then, the search continues, not as pursuit, but as prayer, a quiet affirmation whispered into the cosmic dark, that to be human is to look up, to reach, and to never stop asking. Across the corridors of observatories and the hum of supercomputers, the echo of that silent traveler still lingers. Scientists revisit the data not out of necessity, but reverence, as though each decimal might conceal a whisper of something greater than comprehension. In the stillness of the night, long after the instruments have powered down, the question endures like starlight crossing an impossible distance. What if the universe itself is aware of our curiosity? What if these fleeting visitors are its subtle replies? There is something deeply human about watching the vanishing point of discovery. It is not defeat, but a quiet acceptance that meaning cannot always be captured in measurement. For millennia, humanity has stood beneath the same indifferent sky, naming the constellations, charting the heavens, mistaking their patterns for destiny. 3i Atlas joins that lineage, another myth in motion, another symbol of our refusal to stop wondering. The ancients once saw gods in the stars. Modern eyes see data and trajectory, yet the awe is the same. The difference is only in the language used to describe it. Astronomers speak now of follow-up missions, probes designed to intercept the next interstellar object, should fate align again. But even they admit that technology may never match the timing of the cosmos. For every plan humanity makes, the universe unfolds with a rhythm of its own. The next visitor might come tomorrow, or in 1,000 years. It might reveal itself not in light, but in gravity, distortion, or a whisper of neutrinos bending through the dark. The only certainty is that curiosity will be waiting when it does. Philosophers have begun to reinterpret these moments not as puzzles to be solved, but as mirrors to be studied. The enigma of 3i Atlas reminds them that the universe may not be a system to conquer, but a presence to understand. Perhaps knowledge itself has limits, a horizon beyond which questions become poetry. It is there, at that edge, that science and wonder meet. The telescope and the imagination become one instrument, aimed not outward, but inward. Every civilization must confront this realization, eventually, that its search for cosmic truth is also a search for self. When humanity builds telescopes, it is building mirrors, each discovery revealing a fragment of what it means to exist at all. The light from distant galaxies, the patterns in quantum noise, the trace of a fading interstellar object, all of it forms a portrait of a species still learning to see. In that sense, 3i Atlas is not gone. Its presence lingers in the questions it awakens in the new generation of scientists, inspired to push beyond the horizon of certainty. In the quiet moments when someone looks up and feels the weight of infinity press softly against their thoughts, it remains not in the stars, but in the collective consciousness that dared to imagine more. The cosmos will continue its silent rhythm, unbothered by the brief flicker of human attention. Yet within that rhythm lies the very reason for our existence: to observe, to wonder, to feel awe, even when comprehension fails. The mystery of 3i Atlas may never be solved, but perhaps it was never meant to be. Its true purpose might have been to remind a small, fragile world that mystery itself is sacred, that not everything must be understood to be profoundly real. And so, beneath the infinite expanse, the earth keeps turning, its oceans reflecting starlight older than memory. Somewhere out there, the traveler moves through the void, carrying with it not messages or technology, but the quiet echo of our curiosity. It is a reminder written in motion that wonder is the only constant in a universe forever becoming.